Okay, we're in section 5 of the notes where we're talking about the sums, differences, multiple angles, half angle formulas. Once you get through this written material, including a supplemental problem set, you should do the web assign. That's the Math 120 topic 5, and then try to make some constructive comment in the discussion group if you can. All right, so what do we do here? Again, I emphasize throughout the lecture, hopefully you're paying attention and you can understand what's being presented to you. Again, it's incumbent upon you to understand what's being presented to you. All right, so what we did was derived basically 4 formulas. And the 4 formulas we derived were the cosine of a difference, the cosine of a sum, the sine of a sum, and the sine of a difference. That's incredibly important you know those 4, because everything that follows it depends on those 4. And then we talk about double angle formulas. Again, it depends on what comes prior. We talked about half angle formulas. Again, it depends on what comes prior. And then we talked about product sum formulas. Again, I would not want to memorize this stuff. However, some students decide that that's worth memorizing. I'm going to say it's worth memorizing the first 4 formulas we gave you, which is the sum, the cosine of a sum, the cosine of a difference, the sine of a sum, and the sine of a difference. What did we do in class? We reviewed problems, and the problems that we reviewed were related to those 4 fundamental formulas, all right? So we went through this. Hopefully it's understood. Hopefully you've spent some time doing that. Again, I shouldn't memorize much. However, you may decide you're going to memorize a lot more than I'm suggesting, and that's entirely up to you. Your life will go faster if you can memorize a lot, though, by the way. You won't struggle with deriving things. So we went through a bunch of examples. Eventually, when you get done with the examples, which we did in class already, they were presented to you. I did some side points over about, how to unnest a root and stuff. You don't have to unnest roots, but it's an interesting concept. We talked a little bit about Sage, and I went on and let's see, we eventually got a lot of problems, right? And again, it's risk reinforcing. Some activities, again, I recommend you read a textbook. The textbook that you have in WebAssign is fine. Other textbooks are fine as well. I certainly recommend a lot of different books. One of the books I would recommend is Sham's series because they're cheap and they're paperbacks, and they really very, 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 very good books for problem solving. We're going to be doing the homework now, and I'm going to be moving to the whiteboard. Again, it's important you do this on your own. The reason I'm doing it is for those students that want to watch someone do it. But even if you watch it, you still have to get busy doing things. And the things you're going to be doing is this homework that we're talking through here. All right, so I'm going to switch to the whiteboard. Just give me a second to do that. I'll work through each problem separately. And let's see what I got here. That's an old slide there. Just get rid of that. New slide. And we are now doing the homework. And I want to make sure someone says, hey, where'd the notes go again? Well, I hope you realize we're in section 5 of the notes. And we're doing the homework. I'm going to start with problem number 1. All right, so we're doing section 5 homework. All right, it says use the appropriate sum or difference identities to find the exact value of the cosine of 7 pi over 12. All right, the first thing I'm going to do is I'm going to convert it to degree measure because it might be easier for me to figure out what the sum or the difference might be. So I'm going to take 7 pi over 12 times 180 degrees over pi. All right, certainly the pi's cancel off. And I'm going to divide through by 6. And 6 goes into 12. Give me 1 second. 6 goes into 12 2 times, and it goes into 180, let's see, 30 times, right? So 30 degrees. And then I'm starting to see 2 goes into 30 degrees, 15 degree times. And what's 7 times 15? That's going to be 70 and 35, which is 105 degrees. Oops, let me go back to black ink. All right, so this is the same thing as a cosine of 105 degrees. Then the question becomes is, what do you want to use, a sum or a difference? All right, so I'm going to write 105 degrees. And I'm starting to realize it has something to do with the references that we're talking about. So I'm going to say a good choice for me anyway would be cosine let's see, I'm going to say 45 degrees and 60 degrees. All right. I'm going to use a sum formula. What's it going to be? Cosine 45 degrees. We'll look at the answer later, times the cosine of 60 degrees minus the sine of 45 degrees cosine. I'm sorry. I'm just daydreaming. All right. Sine of 60 degrees. Now, by the way, these should be known now. We've been doing this for some time now. But if you still need to draw triangles, that's fine. And there's nothing wrong with that. A lot of times I'll do it anyway, just because I think it's easy to do. So 1 over root 2. The cosine of 60 would be 1/2. That's 60 degrees, by the way. Minus sine of 45 is 1 over root 2. And the sine of 60 degrees is root 3 over 2. And I'm going to do that arithmetic. And the bottom, same denominator, 2 root 2's. And the numerator is 1 minus root 3. Can put a box in that. Again, I'm not saying I'm not beyond making a mistake. I do want to check my answer key. And the reason we give the answer key is so you can check these things as you move along and develop a sense of confidence about what you're writing down. Looks good. We did fine in that one. All right, fairly simple. Let me go to number 2 now. Again, for the students that are finding this going too fast, what I would recommend you do is, maybe watch them at the end of the week, but most important recommendation I make to you is you really have to start studying the material, going over what we've presented in class, make sure you understand that. And these problems should go very quickly if you followed along with what we've done in lecture. Unfortunately, for some students, lectures are a time to drift off and not pay attention. And you really need to pay attention to what we're presenting to you. Your objective here is to learn. Let's go to number 2. And I'm seeing cosine v plus x minus cosine v minus x. And what do we do when we simplify it? Well, one step at a time. Some formulas, I need to know these. Cosine v, cosine x, minus sine v, sine x. All right, what I do? I did this. All right, now what I'm going to do? Subtract. I'm going to do this guy now. That's going to be cosine v, cosine x, plus sine v, sine x. Well, it looks pretty easy to do, and I'll tell you why. These things disappear. All right, that was good news. What he left off with, minus sine v sine x, minus sine v sine x, which is minus 2 sine v sine x. I'll put a box in that. And again, I'm going to say this over and over again to you, hoping you're catching on to this. Look at the answer key, see if that's what you're staring at. And if you're not staring at that, you got to rethink it. You really do, including, there might be an error in the answer key. All right, let's go to number 3. Put it down for you. And number 3 says, I need to verify something's not true. Well, there's many ways to verify something's not true, but the way I'm going to do it is I'm going to evaluate each side separately and see what happens. I'm just copying at this point. Again, you should be familiar with some formulas. This is going to be cosine 45 degrees times cosine 120 degrees plus sine 45 degrees times sine of 120 degrees. And they're saying this is not equal to, I'm going to move this over a little bit, cosine 45 degrees minus cosine 120 degrees. All right, I'm going to move around. I realize this moving might hurt you. You get dizzy looking at it, but I'll try to summarize. So cosine of 45 degrees, again, I should know this without putting triangles down at this point. But again, if you need to put triangles down, put them down. 1 over root 2. Cosine of 120 degrees, well, that's going to be in the second quadrant now, and the cosine of the second quadrant is going to be negative. The reference would be a 60-degree triangle. So minus 1 over 2, right? Plus sine of 45 degrees, fairly simple. And the sine of 120 degrees, second quadrant, it's a 60-degree reference. Let's root 3 over 2. All right, I'm going to cosine 45 degrees. I can see that. 1 over root 2 minus, I can't remember what's there. oh, it's cosine of 120. I think I just did that. That's minus 1/2. All right, let me see if I can do the arithmetic now. You're going to get minus 1 over 2 root 2 plus root 3 over 2 root 2. And I get a common denominator here. It's going to be root 2, right? And what do you get there? Well, let's see. You get 2, and that's plus 1, but plus 1 times root 2 is plus root 2. All right, let's keep going. This is going to be 2 root 2, and on top you get root 3 minus 1. Clearly, they're not equal. Clearly, they're not equal. How do I know that? Although the denominators are the same, look at the numerators. They're clearly not the same. All right, clearly not the same. All right, so I'm going to say QED. Right. I want to emphasize looking at the answer key. And what I mean by that, I write this stuff down for you. Right, so root 3 minus 1 over 2 root 2. And I wrote this side down over here. And you should be checking that to make sure that you're comfortable with the computation. All right, I'm going to number 4. Relatively simple so far. We're just reinforcing what we learned. Now I'm going to write this one down. It says find the exact value of the trigonometric function given the fact that the sine of A, I'll write this over here for you, is 5/13. And it goes on to say the cosine of B is minus 3/5. All right, now what do they want to know? Well, before they want to know something, they're telling me something about A and B, and they're telling me that A and B are in the second quadrant. All right, so I think I can write this down. So I know the cosine of A is going to be a negative number. It's in the second quadrant. And I know the sine of B is going to be a positive number. And again, it's in the second quadrant. What do I know about the cosine of A? I know its denominator is 13. What do I know about the sine of B? I know its denominator is 5. And I can use Pythagorean Theorem. And, certainly it's not that bad. I'll do A first. It's 13 squared minus 5 squared. It's going to be 169 minus 25, which is 144. So now I know that this is 12 squared. So what goes here? 12. Right, let me erase my work. Again, this stuff can be done in your head. Do it in your head. All right, let me do the other one. The other one's going to be 5 squared minus, well, I'm going to put down minus 3 squared over here. All right. What does that give you? 25 minus 9, which is 16. So now I know this is 4, because 4 squared is 16. I'm going to erase her out. Again, this is old material. We're hoping that you understand this material. If you don't, though, you're in the wrong section of the notes. All right. So what do they want me to evaluate? They want me to evaluate the sine of A plus B. Well, I need to know the sum formula. Sine of A, cosine of B, plus sine of B, cosine of A. Well, let me write this down. What's the sine of A? 5/13. What's the cosine of B? Minus 3/5. Plus, what's the sine of B? 4/5. Again, I'm just reading what's above it. What's cosine of A? Minus 12/13. Let's go through the arithmetic. Common denominator, looking at it, 5 times 13 is 50 and 15, which is 65. What do you get on top? Minus 15. 5 times minus 3 is minus 15. Minus, well, 4 times minus 12 is minus 48, right? And what does this give me? Well, let's see, 15, maybe 53, 63, right? So minus 63 over 65. I can put a box in that. And again, I say this over and over again. Hope you're sick of hearing it. Look at the answer key. Make sure you can agree with it. And if you can't, there's something horribly wrong somewhere. All right, I'm going to go to number 5 now. Again, these are relatively simple questions. They're not really testing any knowledge about this, other than the fact that can we do what we've been told to do in class or shown in class. What are they saying over here? They're saying sine of x is an angle, right, is minus 5/13. And they say x terminates in the third quadrant. So I'm going to draw a picture of this one over here. All right. Now, someone says, why do you do that? You don't have to. But if I were looking at this over, it terminates in the third quadrant. And I know the radius of the circle is 13. right? And I know that sort of to me, that's a pretty big circle, 13, right? And the abscissa, right? And the ordinate. And I'm wondering, what does the -5 give me? Does that give me the abscissa or it gives me the ordinate, right? So I'm going to say, if I were to look at that, I'm going to say it looks sort of like this over here. All right. Let me point out what I mean by that. There's going to be an angle, X. I'm going to say abscissa and ordinate. No, you don't have to label it. All right. You don't have to draw the picture. But I know the angle. Now, I know the radius too. The radius is 13. All right. We're just reviewing what you've done in the past. Now, what do I know? I know the ordinate's -5. That means the B is -5. Let's see if we can get the abscissa. And I know the abscissa is negative, by the way. Pythagorean theorem again. What do I have? 13 squared minus -5 squared. I think we just did that. That's 144, right? So it's going to be plus or minus 12, but I hope you realize you're looking at a picture. I hope you realize it's -12. All right, let me get my eraser out. And I'm going to erase this business over here. Someone says, I don't even think they asked me to do that. You're right. Maybe they didn't ask us to do that. But I think I can write other things down now. For example, I can write down the cosine of x. And what's that going to be? Well, looking at my picture, that's going to be what? That's going to be minus, you know what? Did I get it backwards? No, I'm sorry, -12 over, I'm sorry about that. Nothing's backwards there. So what I'm going to do now is I'm going to look what the question is. And so I don't know what the question is. And the question is the sine of 2x. Now remember, I boiled everything down to sum formulas. Let me write this down for you. This would be sine of x plus x. What would this give me? Sine x, cosine x, plus sine x, cosine x. And we derived this in class before. So the sine of 2x is just simply 2 sine x, cosine x, right? This is a formula that we said you probably should be able to derive pretty quickly. Let me write this down then. Sine of 2x is equal to 2 times the sine of x. What's the sine of x? Minus 5/13 times the cosine of x. That's minus 12/13. Let me go through the arithmetic. 13 times 13 is 169. And over there, you would get a positive number, and you would get 2 times 5 is 10, 10 times 12 is 120. Again, you hope you're getting sick of me saying this. Mistakes happen. And I'm the first one to fess up to a mistake. And I want you to also fess up to mistakes. What am I looking at? The answer key. See if I got it right. Where they say 120 over 169. All right, let me go to number 6. And again, we're not asking to memorize much. Actually, we're not asking to memorize anything. We're asking to understand the material. But again, for a lot of students, that's a difficult thing to do. So what I want to write down is, the tangent of a sum. So I'm going to put a plus b down. And I guess I should know that one. And let me just write this down. This is really, the sine of a plus b over the cosine of a plus b. Right? You could do that, right? I mean, certainly they're easy to do. And so why would I do that? Well, so French for memorizing things. And I could also write down tan of a difference, right? And that would be sine a minus b over cosine a minus b. All right, now the question is, looking at the problem number 6, I'm looking at the top and it's a difference. So I'm going to say it clearly looks like this one over here. All right, so I'm going to write it down for you. And it's a lot of work to write things down. I still want to write it down for you. Tangent a minus b is equal to, let's write this down, sine a sine b. I'm sorry, I'm daydreaming again. Sine a cosine B minus sine B cosine A. Let's go to the bottom. Cosine A, cosine B, plus sine A, sine B. Now, I realize what some students argue. They're going to say, I think it's easier to memorize things than to be able to do things in a reasoning skill set. And I'm not going to deny it. It's much easier if you can memorize. All right, I'm going to keep going here. And what I'm going to do here, I'm going to divide top and the bottom. I'm going to circle it for you by this. And what would I get? If I'm dividing that term by cosine A, cosine B, and we're at the bottom now, it'd be 1 plus, what would I get over there? So we get sine A over cosine A, which would be tan A, and cosine B over sine B, I'm sorry, sine B over cosine B is tan B. I'm really daydreaming here. What do you get on top? Sine A over cosine A, which is tan A. Minus, well, again, I'm divided by cosine A, cosine B, and you get sine B over cosine B, which is tan B. All right, I'm going to put a little checkered box in this one over here, indicating, again, some students say, I'm going to memorize that. And you could. And let's write this down now. And I'm looking at the problem now, and I'll write it down for you. And what is it? Tan of 175 minus the tan of 55. And what goes on the bottom? 1 plus the tan 175 and tan of 55, right? And they certainly write these problems to work out nicely. What you go on this side over here? Tan of a difference. And what's the difference going to be? Well, looking at it, what's the A? 175 minus the B, which is 55, right? Let me move this up. Yes, we spent time deriving that. We've also done that during lecture. So what's it going to be equal to? The tangent. Let's see, 175 minus 55 is 120 degrees, right? All right. Again, if you need to draw a picture, that's fine. It's a reference of 60. And what are you going to get? Well, you're going to get, root 3 over 1, but it's in the second quadrant. It's going to be negative, so minus root 3. All right, let's look at the key, and that's what I'm staring at. I feel comfortable with that. All right, let me go to the next one, which is number 7. What does 7 say? It says, suppose the cosine of x equals a half. I'll write this down for you. Again, the x is representing an angle, and a half is the ratio. And then it says the sine of y, again, y is some angle, is equal to 1/2. It says x and y are in the first quadrant. Well, this should be easy then, right? So I know the sine of x, if it's in the first quadrant, right? Again, it says that x terminates in the first quadrant. I'm going to still get 2 for a denominator. And then what do I get? I would get, let's see, I get root 3, right? Right, Pythagorean Theorem, 4 goes 2 squared is 4, and 4 minus 1 is 3. So root 3, okay. And now what do they say about the y? They say y is in the second quadrant. So I know the cosine is going to be negative there. Same thing, denominator is going to be 2. What do you get for the numerator? Well, I just did it. It's going to be root 3. All right. Now, what's their question? Well, their question is this. What's the sine of x minus y? Well, it's going to be sine of x times sine of y. I'm sorry. I keep doing that. I'm just not thinking. I'm daydreaming. Cosine of y minus sine of y cosine of x. Well, let's write this down. What's the sine of x? Root 3 over 2. What's the cosine of y? Minus root 3 over 2. Minus, what's sine of y? 1/2. What's cosine of x? 1/2. Let's do the arithmetic. The denominator is the same in both cases. It's 4. What do you get there? Minus 3, minus 1. Minus 3 minus 1 is minus 4. And minus 4 divided by 4 is -1. Again, these are written to work out nicely. Again, look at the key. Make sure you can agree with that. All right, let's go to number 8. Relatively simple. Find the exact value of the trigonometric function given that sine of A is equal to -15/17, and the cosine of B is -4/5. They tell me these things terminate in third quadrant. So let's put this down. Cosine of A, this comes from the reading of it, by the way, 17 in the bottom, and the sine of B would be 5 in the bottom. So before I do anything, I want to get the signs of it. So in the third quadrant, the cosine of A would be negative, and the sine of B would also be negative in the third quadrant. Again, this goes back to older material. If you need to draw pictures, that's fine. All right, now 17 looks like a big number, so I'm going to do the 5 first. And what would that be? 5 squared is 25. Use Pythagorean Theorem. And then, the -4 squared is 16. And that would give you 9. So now I know this number here is 3 because 3 squared is 9. Let me erase this over here. This one's a little more challenging for me. So I want to write down, certainly I got to do 17 squared, right? Well, let's just do it. 7 times 7 is 49. 7 times 1 is 7. 7 plus 4 is 11. And then I got, 10 times 17 is 170. So you get 9, 8, 289, right? That's not bad. I got to do 15 squared now, don't I? Again, it's easy to do, but I want to go through it. 5 times 5 is 25. 5 times 1 is 5. That's 75. And then 150, which would be 225. So it's going to be 289. I'll erase this work later because it's like baby work. What do you get there? 4, 64. Wow. So if it's 64, what square gives you 64 is 8. I'll write that down over here. Right, let me get my eraser out. This is my side work. It's baby arithmetic. But again, it's important you're able to do that without resorting to a calculator. If you do it in your head, please do it in your head. All right, and so say, I lost track of this. I don't know what you're going to do now. I'm going to answer the question. And what's the question? The tangent of B minus A. Now someone says, do you want to derive the formula for that? And I don't. What I'm going to write down is this is going to be the sine of B minus A over the cosine of B minus A. And I should know those formulas. So what do you get over here? Sine of B, cosine of A, minus sine of A, cosine of B. That's not so bad. This can be cosine B, cosine A, plus sine B. That's a B, sine A. I'm going to start popping numbers in. What's sine of B? Minus 4. This. We'll do the arithmetic later. What's a cosine of A? Minus 8 17ths. Minus, what's a sine of A? Minus 15 17ths. Again, we'll do the arithmetic later. I'm just copying. What's cosine of B? Minus 4 fifths. Let's go to the bottom. I know they're fractions, don't I? Okay. What's cosine of B? Minus 3 fifths. What's cosine of A? Minus 8 17ths. All right. What's a sine of B? Minus 3. You know what? I think I copied wrong. And I apologize. I'm just noticing that now. My eraser out. I said the cosine of B was minus 3 fifths. It's actually minus 4 fifths. I'm going to check all my work, by the way. Let's see, cosine of B is minus 4 fifths, right? And someone says, why did that happen? I've got them written in different orders. So I'm going to erase this now. And I want to point out, this is just me. It may not be you. It's part of my reading. I'm not sure why it happened, but it does happen. All right. And I want to point out why it happened. I had these things written in a different order of these things over here. So I'm going to, maybe just reorder it for you. And let's see. So I'm going to write it here as cosine. Whoops, I'll put it over here. Cosine B is minus 4 fifths. Got my eraser out. Not just me, by the way. I'm not saying it's you. Okay, let's do it again. I'm just copying. Some people think it's too much work. It's really not much work. Minus 3 fifths. That's a sine of B, right? And the cosine of A is minus 8/17. Let's see, sine of A is minus 15/17. Cosine of B is minus 4 fifths. Let's see, cosine of B minus 4 fifths. The cosine of A is minus 8/17. These numbers are going to work out nicely. Don't worry about that. The sine of B is minus 3 fifths. And the sine of A is minus 15/17. So someone said, what do you notice about this thing? I noticed that every single denominator is 5 times 17. So what I'm going to do is multiply the top and the bottom by 5 times 17. And I get something really easy now. So for example, the first term, the 5 and the 17 cancels off. Then we're left with minus 3 times minus 8, which is 24. Next term, well, the 5 and the 17 cancel off, and I'm left off with, 15 times 4, minus 15 times minus 4 is 15 times 4, which is going to be 40 and 20, which is 60. All right, let's go to the bottom. What do you get there? Well, the 5 and 17 cancels off in the first term. You're left off with minus 4 times a minus 8, which is going to be plus 32. Let me get my eraser out. 32. Plus, let's see what you get over there. And the 5 and 17 cancels. And you left off at minus 3 times minus 15, which is 3 times 15, which is 45. Again, I'm not saying I didn't make any errors, but I want to get to the end of this. And 32 plus 45 at the bottom is going to be 77. 24 minus 60, definitely negative number. That's going to be 36, right? Okay. Oh, thank God I got the right answer. I really mean that. Right? No mistakes. Let's go to number 9. And for a lot of students, what happens to them is they say, oh my God, what's that thing? How can I do that? And I don't want you to memorize too much. I can write number 9 down for you. And it's a sum. Now, I don't ever remember seeing a multiple of 7 for an angle. So I'm going to read it. It says, write this thing as a product of trigonometric functions. So I'm going to claim this has something to do with the functions that we talked about. The identities we talked about, the 4 of them. So you like the cosine of a sum, cosine of a difference, right? And the sine of a sum, sine of a difference. I'm going to write this down. Let's just give it a shot. I'm going to write down sine A plus B. And I'm going to write down sine, and I should know these, by the way. This can be sine A cosine B plus sine B cosine A. That's not so bad. This will be sine A cosine B minus sine B cosine A. So what I'm going to do is look at these, and I'm going to add them together. And I'll tell you what I get. I get sine. We did this in class 2. A plus B plus the sine A minus B. And what's that equal? 2 sine A sine B. All right. So I want to point out what happened over here. This is a sum. That's a product. So we gave you 2 sets of formulas. One was product to sum. The other one was sum to product. Well, I got a sum. They want the product. So what do I now know? Looking at it, I want to point out what I got over here. a plus b must be 7x, and a minus b, right, must be x. Let's put this down. I'm sorry, I copied wrong. That's a 3x. I'm write this down for you. You know what? I'm going to get the ratio out to make it a little bit neater. So what do I know? A plus b is 3x. And I know a minus b, I'm sorry, I did it again. A plus b is 7x. And a minus b is going to be 3x. Well, I'm going to add these two together, find out what a and b are. And what do you get? 2a equals 10x. Well, that's convenient. What's a going to be? 5x. What's b going to be? Let's look at it. What is b going to be? Well, look at it. A plus b is 7x. And if a is 5x, b would have to be 2x. Let's look at the second equation. It says a minus b is 3x. Well, 5x minus 2x is 3x. So let's write this down. What do you get? The sine. What's a plus b? 7x plus sine. What's a minus b? 3x is equal to 2 sine. What's a? 5x times sine. And what's b? 2x. A box in this. I took the sum, or as a product. What we'd like you to do, we certainly want you to look at the answer key to see if you're staring at that. And if you're not, you got to really consider something has to be wrong. All right. There's also some code there for Sage. Maybe I'll do it a little bit later, but right now I want to move on to the next question, which is number 10. What's number 10? Find the exact values of the sine of 2x, cosine of 2x, tan of 2x using the double angle formulas. Let me write this down. Cosine of x is minus 2 sevenths, and they tell me x is between pi over 2 and pi, second quadrant. So I think I can write this down now, the sine of x. The denominator would be 7, going to be a positive number. What would I do? Pythagorean Theorem, 49. 7 squared is 49. You know, minus a minus 2 squared is minus 4. So that's going to be 45. And certainly I know that this is going to be root 45 over here. And I'll put this over here. I'm going to erase this in a second, by the way. Whoops, I went backwards on that one. Must be daydreaming. Well, that's like the square root of 9 times the square root of 5, which is 3 root 5s. Okay, get my eraser out. Erase this business over here. All right, someone says, why'd you do that? Well, typically I need to know sines and cosines to evaluate the other trigonometric functions. First thing they write down, and you should know this formula, by the way, and it comes from the sum formulas. We've derived these in class. It's going to be 2 sine x cosine x. Well, I can write this down. 2, the sine of x is 3 root 5 over 7, and the cosine of x is minus 2 sevenths. Let's write this down. It's going to be 49 in the bottom. And what do you get on top? You definitely get a negative number. You get 12 root 5s. We'll look at that later. I'm not saying it's the right answer, but I want to look at that later. Next thing I'll do is cosine of 2x. There's a variety of ways of writing this thing down. You could write down as cosine squared x minus sine squared x. And yes, we derived these in class. If you can't remember them, they're really easy to derive from the sum formulas. You could also write down 2 cosine squared x minus 1, or you could write down 1 minus 2 sine squared x. I'm going to do all three, right, and see what we get. They should be the same, by the way. What's a cosine squared? Well, looking at it, it's going to be 4. Because minus 2 is 4, right? 7 times 7 is 49. Minus, what's a sine squared? Well, let's see. That's going to be 45 over 49. All right, let's do the next one. It's going to be 2 times cosine squared, which is 4 over 49. minus 1. We'll do the arithmetic later. And this can be 1 minus 2 times the sine squared, which can be 45 over 49. All right, push on the side and do this. This is minus 41 over 49. This is going to be 8 49ths minus 49 49ths. Well, gee, that's also minus 41 49ths. No kidding. It should be. This one's going to be, let's see if I did this one right here. 49 49ths minus 90 49ths. What does that give you? Minus 41 49ths. They're all the same. All right, so I'm going to put it, I got a box on that. And now I'm going to write the tangent of 2x. No, I'm not going to write a formula. This is going to be the sine of 2x over the cosine of 2x. Let's write this down. So it can be minus 12 root 5 over 49 minus 41 over 49. That looks pretty simple. What are you going to get over there? A simple arithmetic. It's going to be a positive number. The 49s multiply top and bottom 49. You're going to get 12 root 5 over 41. Put a box on it. I'm going to get my red pen out and look at the answers. Where they say the sine of 2x is minus 12 root 5 over 49. What did it say the cosine of 2x is? Minus 41 over 49. What did it say the tan of 2x is? 12 root 5 over 41. Looking pretty good. All right, let's look at number 11. Again, for some students who look at these things and don't know where this stuff comes from, again, you need to study what we're presenting to you in the course. All right, those notes. What's 11? It's 5 cosine squared 2x. And they want me to write the expression in terms of first powers of the cosine. Well, you know, someone's going to say, why would you want to do that? Later on in mathematics, if you can take something that's a square and make it linear, that's a really nice thing if you can do it. All right, so let me write some things I do know. And I'm going to write down some things that I do know. I know that, for example, let's see, the cosine of 2x, right? Again, there's some things I do know. You know, I'm going to use theta because I don't want to confuse with the x in the problem. Raise this over here. So I know the cosine of 2 theta. We just did a prior problem, right? I can say 2 cosine, cosine squared theta, minus 1. That's a thing over there. So I'm looking at that. I'm going to try to solve for the cosine squared. So I did cosine 2 theta plus 1 over 2 would be the cosine squared theta. All right. Now someone says, what's the theta? Well, I'm looking at it, and the theta would have to be 2x. I'll do that later, by the way. But I also know it's a coefficient of 5. I'm going to install that now by multiplying both sides by 5. So 5, this is 5 cosine squared. Now again, I'm going to say theta is 2x now. So if theta is 2x, what do you get over here? Cosine, what's 2 times 2x? 4x. Okay, let's look at the K. See if we got it right. And I'm looking at it. Yeah, we got it. We took a square, we wrote it as a linear problem, which is great news. Let me get to number 12. Number 12 is half angle formulas. All right, before I do that, I want to point out I'm seeing an angle here, which is pi over 12. I'm going to convert it to degree measure. That's 180 degrees over pi. What do I know here? Pi's cancel. I'm going to divide through by 6 first. That would be 2. This would be 30 degrees. And what's 230 degrees? 15 degrees. I'll write that down for you now. What do they want to know? They want to know the sine of pi over 12 or the sine of 15 degrees. Now my claim over here, they said use half angle formulas. So I'm gonna write this down as a half angle. Sine 30 degrees over 2. All right, that's letter A. We'll do that later. And letter B is cosine pi over 12. That's going to be cosine 15 degrees, or the cosine of 30 degrees over 2. They also want to know the tangent of pi over 12, which is really the sine of 15 degrees over the cosine of 15 degrees. Yeah, that's not so bad, which we know to be the tan, right, of 15 degrees. Someone says, do I know those guys? Not yet. Let's write them down. All right. Go through this, go through the ringer, so to speak, on it and see if I can do it. All right. So they said use half angle formulas. And someone says, I don't even know what half angle formula is. We're going to write them down for you. So I write down cosine squared theta. We just did this, right? I'm sorry. I'm going too quick with that. I shouldn't have written that. I shouldn't have written that down. I'm going to erase that right now. Cosine of 2 theta is 2 cosine squared theta minus 1. Cosine 2 theta plus 1 over 2 is cosine squared theta. And I'm going to make a substitution over here, half angles. I'm going to let x equal, I'm sorry, another theta equal x over 2. And what do you get over there? Cosine, well, 2 times x over 2 is just x, right? Plus 1 over 2, right? Right. I can't remember what I'm talking about. I'll go back and look at the notes. I'll scroll back. I'm going to do another one. I'm going to write down cosine of 2 theta. Can also be written as 1 minus 2 sine squared theta. Well, I'm going to solve again for sine squared. You would get 1 minus cosine 2 theta over 2. And I'm going to do that x over 2 business now. So what are you going to get over here? Sine squared x over 2 is 1 minus cosine of x over 2. Right? Not so bad. All right. So what are you going to do with that? And I'm going to start to solve these things. And this is where the problem comes in, because a lot of students just don't know what we're doing over here. And what we're doing is trying to get a formula. So I'm going to push this up. I'll write the formulas down for you. So I'm going to put down the cosine of x over 2. I'll put out what we're doing over here. Looking at this over here is plus or minus the square root of that. And this is where all hell breaks loose. So plus or minus. It can't be both, by the way. So I'm going to say cosine x plus 1 over 2. And next one, I'm going to put down, let's take a look, the sine of x over 2 equals plus or minus 1 minus cosine x over 2. All right, so this is what do you want to do now? Well, I'll be real. I want to be at 15 degrees here, right? I'll push this up. So I want to do the cosine of 15 degrees, which is the cosine of 30 degrees over 2. I hope you realize this must be a positive number. So what do you have here? Cosine 30 degrees plus 1 over 2. We'll do that later. I also want the sine of 15 degrees. What does that give me? The sine of 30 degrees over 2. It's still positive, 15 degrees in the first quadrant. So it's plus 1 minus cosine 30 degrees over 2. I'm going to do the arithmetic for you. I know that's tough. Cosine of 30 degrees, that's going to be root 3 over 2, right? Plus 1 minus root 3 over 2. Still going to do some simplifications. multiply top and bottom by 2. What are you going to get? Root 3 plus 2, and 2 times 2 is 4. This looks pretty simple. What do you get? Root 3 plus 2 over 2. Same deal, multiply top and bottom by 2. You're going to get 2 minus root 3 over 4, which is going to be the square root of 2 minus root 3 over 2. Let's write the tangent now of 15 degrees. It's just simply the ratio of sine over cosine. And someone says, I don't even remember what we're talking about over here. I got them written down. What's the sine? Well, it's going to be this thing here, 2 minus root 3 over 2. And the cosine was this one over here, which gives me this. This is cosine, 15 degrees. This is sine, 15 degrees. This is tangent of 15 degrees. All right, I'm going to the answer key. As I do that, I want to encourage you also to look at the answer keys to make sure that you can agree with what we're stating these things are. A little red pen out. And the first thing I'll do is this sign. And where they say it's equal to, let's take a look at it. I'm looking at this guy over here. And I see it. I see the 2 minus root 3, the root of it, 2. They also unnest the roots. If you want to do that, you can. Let's look at the cosine. Looking at this now, see if I got that right. And let's see. Yep, they also unnested the root, and that's fine to do that. I noticed the tangent, I wrote something down different than mine. I'm not going to go through that with you. So I'm going to write this as, again, I want to get, I'm looking at this thing, and I notice they don't have that one written down. So I'm going to write down what I think they might have done. And this is going to be, let's see, 2 minus root 3, and the bottom is 2 plus root 3. I guess what they did is rationalized by multiplying the bottom by 2 minus root 3. 2 minus root 3. What would this give me? Well, this over here, it would give me 2 minus root 3 squared on top. And what do you get on bottom? Well, 2 times 2 is 4, and its conjugates, so middle terms disappear. 4 minus 3 is 1. Wow, that looks like it's pretty simple. What would you get over there? 2 minus root 3, which is equal to 2 minus root 3. Put a box in that over there. Again, that's what they have written in notes, and that's what you pay careful attention to. All right, I'm going to, my pen is running dry here. I'm going to have to charge it up. I'm going to switch screens momentarily, and we'll come back to the next question later. All right, just give me 1 second. I need to recharge my pencil a little tiny bit. This happens to me sometimes. Batteries go dead. And I'm going to go back and do another screen share with you. And give me 1 second to do that. So screen share, new share. I'll share my desktop with you. Okay, so we just did, up to problem number 12. I'll come back and I'll finish 13, 14, 15, and 16. What I'd like to do is I'd like to go to Sage though. All right, so give me 1 second to do that. And just give me a minute here. I gotta get this out of the way. I'm doing it from terminal. Again, for those students that do not want to use the terminal, go to CoCalc on sagemath.org, and you simply can do this on their website by using CoCalc. All right. What I want to do is I want to just simply look at problems and see if I can do them, and I'm gonna I definitely want to look at my code. All right, the code's over here, and I want to see if I can type that code in. All right. Now, again, when my pencil charges up, I'll go back to the other problems, but I'm going to, look at some simple code over here. And the first thing I'll do is I'm going to look at number 16. All right. And it looks tough. I'm not saying it's an easy problem to do, but I'm going to see if I can type it in. All right. Now, I'm going to cut to the chase over here. My Python's launching, by the way. You know what I should do when I'm doing that? I should go to the website. I'm launching a server right now. It takes time to launch it. And we're going to go to sagemath.org. And remember what I said about the CoCalc. You can just click on this CoCalc link here. Again, you may have to register an account. I would recommend you do that, though, and come familiar with how to do that. It's starting CoCalc up. I want to emphasize when you do that, you can create a new worksheet if you like. All right. You don't have to, but you can create a new worksheet if you like. I'll say, okay, over here. And let me point out, you see the little button here, it says new. I'm going to click the new thing and then Sage Worksheet. It's going to load a worksheet and you can type in commands like 1+1. Remember, if you hit the return key, nothing's going to happen. You have to hit Shift Return for it to make a computation. Now, I want to point out, look up here, it's actually not going to give a result because it's launching a server, right? Once the server decides it can be launched, it'll spit back what the answer is. You're at their mercy, though. Now, when I'm using my terminal, I'm not at their mercy. I'm at my mercy, right? I'm the one who launches the server. The server's running on my machine now, right? Sage is running on my machine. It's using my Python. So let me go back and I'm going to type this stuff in, reset. I'm looking at the screen. And I notice I define a variable, x and h, var, x, whoops, and h. You get the idea? And then they say f of x is assigned. This is not an equality, it's an assignment operator, the function sine of x. And then they say bool. What does bool stand for? It's a Boolean. It'll return either true or false. I'm getting a little tired. So what I'm going to do is I'm going to copy. As I do it, though, I want to go back in the notes and point out what they're doing over here. Let me point out what they're doing. So what they're doing over here, they are taking this side here, f of x plus h, minus f of x divided by h, and they're wondering, is it the same thing as this side over here? Right? They just simply type it in. And what's it going to be? F of x, which is sine, cosine h minus 1 over h. They just simply copied this over here and did this over here. And things worked out fine. I said it's true. Again, when I go back to the notes, I'm going to do that by hand, or at least I think I'll do it by hand. All right. If you do the other stuff over here, there's other Booleans over here. You can do that as well. All right. I do want to point out they can evaluate things that might seem rather odd to you. Someone says, why do I need to do that by hand then? You need to learn how to do this stuff by hand. You'll never get to the machine level of being able to, formulate problems unless you can do simple stuff by hand. All right, I'm going to go back to the whiteboard now. And I know this is tough. Go back to the whiteboard. I gave my pencil a little bit of a charge. And I'm going to go back to the whiteboard. And let me just do that. Okay, what do we do? We got up to problem, just to remind you. And again, I'm looking at the notes again. You should be looking at this as well. We're up to problem 13. All right, so let me put that down for you. And 13, they want me to solve for x, and the x is on an interval between 0 and 2 pi. That's like saying it's between 0 degrees and 360 degrees. All right, now what is it? It's sine of 2x plus cosine of x is equal to 0. Well, first thing I notice is that I really need to, take that sine of 2x and write it in so it has like one angle in it, not double angle. So do I know that formula? I do. It's 2 sine x cosine x plus cosine x equals 0. And then when I'd factor it, and a cosine x comes out, and what am I left off with? 2 sine x plus 1 equals 0. Now, what do I know? I know that this thing is a factor, and I'm using the zero product rule, and this is a factor. Both of those factors have to be equal to 0. Let's write that down for you. Cosine of x is equal to 0, or the next factor, sine of x, would have to be equal to minus 1/2 for that to be equal to 0. So I'm pretty comfortable. I've done these before, and I want to point out what I mean by that. Cosine curve looks like this. Where does it equal 0? Here and here. You should know what those numbers are relatively quickly. What's it going to be? X is going to be 90 degrees, and the other one's going to be 270 degrees. Let me point out over here, 0 degrees, 90 degrees, 180, 270, 360. Let's do this now. A little more challenging. I'm going to do the sine function. Looks like this. And minus 1/2, sort of like this over here. Hits it here, hits it there. The question is, where does it hit it? I certainly know it hits it between 180 and 270, and then 270 and 360. What's going to be the reference? Let me make sure I understand what I mean by that. The sine function is going to be references. This would be its reference. The reference, I'll write this over here, is 30 degrees. All right, let's write this down. So in this second one here, the reference is 30, and the first angle is between 180 and 270, so it'll be 210 degrees. The next one's going to be between 270 and 360, so it's going to be 330 degrees. All right, now that's between 0 degrees and 360, but they spoke in radian. So I need to write down the radian measure, and I'll do that for you now. All right, so let's put that down. X would be equal to pi over 2 and 3 pi over 2. Now 210 has something to do with 30 degrees, and 30 degrees would be pi over 6. So this would be x equals 7 pi over 6 and 11 pi over 6. All right, let's write this down, and I'm going to write them in order. So pi over 2. The next one is going to be 7 pi over 6. All right, just clicking these off over here. And then let's see, 3 pi over 2, right? And then 11 pi over 6. Let's look at the answer key. So if you got it right, pi over 6, 7 pi over 6, 3 pi over 2, 11 pi over 6. I feel good about that. Let's go to number 4. I'm sorry, number 14. What's 14? Oh boy, they give me cotangent of x equals minus 9, and they tell me the x is between 3 pi over 2 and 2 pi. All right, so I don't like cotangent, so I'm going to write tangent down instead. Tangent of x. That would be minus 1/9. All right, I'm going to do a little picture over here. And I'm going to say, sort of like this over here. It's between, and this is the angle x here. I'm going to write this point down for you. And let's see what that's going to be. It's going to be, clearly look at the abscissa, the A is 9, and the ordinate is minus 1. All right, what's the R? Well, it's going to be the square root of 81 plus 1. So the R is going to be the root of 82. All right. Someone says, why'd you do that? Well, I want to get things boiled down to sines and cosines, and I'll write this down for you. So the sine of x and the cosine of x, it seems like I do this very problem. Get it down in terms of sines and cosines. Root 82 on the bottom, root 82 on the bottom. And let's see, the sine is going to be what? Minus 1. And this is going to be 9. All right. Again, we have answer keys. By having an answer key, I certainly would like to know what the result is. And their first question is, what's the sine of 2x? Well, it's going to be 2 sine x times cosine x. Let's write that down. What's sine x? Minus 1 over root 82. What's cosine x? 9 over root 82. Well, I think I can do that. What's that going to give me? Minus 18 over 82. I'm going to reduce that by dividing by 2, minus 9 over 41. All right. So I'm going to look at the key. I'm looking at the sine of 2x, and I'm seeing it. Now I'm going to do the cosine of 2x. Okay. There's many ways to write it down, but I'm going to write this down now. 2 cosine squared x minus 1. There's actually 3 formulas for this, but I'll just use this one over here. For what cosine squared is going to be 81 over 82 minus 1. I think I can do that. That's 81 over 41 minus 41 over 41, which is going to be, let's see, 81 minus 41 is 40 over 41. Again, I check my K. What's cosine of 2x? 40 over 41. What's the next one they asked me for? What's the tan of 2x? No, I'm not going to put another formula down. I'm just going to do sine over cosine. What's sine? Minus 9 over 41. And what's cosine? 40 over 41. Multiply top and bottom by 41, you get minus 9 over 40. Again, I'm going to look at my answer key. I'm looking at the tan of 2x, minus 9 over 40. All right, let's go to number 15. And I want to verify identity. I can't say one side's better than the other, but for the sake of argument, I'm going to pick this side over here. All right, if it doesn't work out, I'll just jump ship. So what's going to be sine of 2x over cosine of 2x. That's not so bad. I can do that. And what's this give me? Get my eraser out. And that would give me, let's see, 2 sine x cosine x. That's not so bad. Now what's the bottom identity? I guess that would be cosine squared x minus sine squared x. All right, what am I going to do now? I'm going to divide top and bottom by cosine squared. Now, it's almost why you do that. Notice there's a 1 in the bottom. What do you have here? Minus tangent squared x. Now I'm going to divide the top by cosine squared. What would you get? 2 sine x over cosine x, because one of the cosines would cancel, and that would be tan x. Gee, that worked out nicely. Q, E, D. All right. All right, let's keep going. And I'm at 16 now. And 16 is the one we just did with Sage. And what does it say? F of x is sine x. And they want me to verify something, and I'll put it down for you. They want me to verify that f of x plus h minus f of x over h is equal to sine x times cosine h minus 1 over h plus cosine x, and move this over a little tiny bit, times sine h over h. Let's get to busy. First one, I'm going to do the f of x plus h. All right, we're going to do this thing over here. We're going to verify that this left side's identical to the right side. So what do you get? F of x plus h would be sine of x plus h, which would be sine x cosine h plus sine h cosine x. Again, I'm just doing the left side now. Minus sine x all over h. All right, I'm looking at it. And what I'm pointing at over here, I'm looking at this and this. And I'm going to pull them together. And as I do that, I'm going to factor out the sine x. All right, so again, I'm moving forward. And what do you get? Cosine h minus 1 plus sine h cosine x. I'm still going forward. And I want to make sure I can get that other side that they say. Let's put this down. I'm kind of looking at it now. And what do I see? I'm going to split into two terms. For the two terms, this one here, and then this one over here. Let's write that down for you. Sine x times cosine h minus 1 over h plus cosine x times sine h over h. Q, E, D. That's what we want to come up with. All right. Pretty easy to do by hand. I think typing it in would take a lot longer. All right. That clears out the assignment. I know it was a long one, but I'm going to be honest with you, you really do need to spend time and effort in being able to do the problems that we present to you. And we're presenting these problems to you. Now, again, there's a lot, different problems out there, whatever you're comfortable with. Okay.